Okay, so let's see why this question was so difficult. All right, so figure 1 and 2. Okay, they're shown above. We got 1 over x. We got 1 over x squared. Let R be the region bounded by the function, by the x-axis, by the vertical lines 1 and 5. Okay, first of all, A, find the region, the area of region R. So here it is, guys. I mean, if you want to find the area, it's just the integral from 1 to 5 of top minus bottom. But really, we just have 1 over x. That's it, right? It's not a calculator question, so what's the antiderivative? ln of x evaluated from 1 to 5. Plug it in. ln of 5 minus ln of 1. Some students left it like that, and I give them the points, but you should know what ln of 1 is. So it's 0. So then the area is ln of 5. You get 2 points for this. 1 for setting it up with the integral, and then for the answer for ln of 5. Okay, I'll just read off my paper. For question B, region R is the base of a solid. The cross sections perpendicular to the x-axis are a rectangle. Okay, just reading that alone, I'm already thinking this. Volume equals the integral from A to B of the area of the cross section. And they already told me what the area is. It says the area is x e to the power of x over 5. So the integral from 1 to 5 of x e to the power of x over 5. That's it. You don't got to do anything else. Some people try to multiplying it by 1 over x or doing something else, but it's always the area of the cross sections. Now, that's just the setup. That's the first point. Now, the integration part is the challenging part because this is integration by parts. You got two functions being multiplied. So you got to find your u and your dv. U should get simpler when you derive it. What do you guys think? Which means the u should be the x. And then dv, it should be something you can integrate. And it does require u substitution, but hopefully you can do it without it. It's going to be itself times something, times 5. So then, our integration by parts, it's uv minus the integral of v du. I don't like it when it gets laggy like that. Oh my god. Okay. U v. I'm gonna put the 5 in the front. E to the x over 5. But that part still has to be evaluated. It has to be evaluated from 1 to 5 minus the integral of v du. That was another point, the structure of integration by parts. And now just finish it. Okay, plug in the 5. So that's going to be 25 e to the 1 minus 5 e to the 1/5 minus, and let me switch the colors here so you can see the difference. I need my antiderivative. It's going to be 5 e to the x over 5 times something, times 5. So I'll just put a 25. Evaluate it from 1 to 5. Okay, well, that's going to be 25e minus 5 e to the 1/5 minus, plug in the 5, 25e minus 25e to the 1/5. All right, let's combine some like terms. Hopefully I haven't messed up. Oh man, I have like no space here. 25 25e minus 25e. They cancel each other out. Negative 5e plus 25e. And they have the same power, so we can just combine them. So then 5 negatives, 25 positives, 20 positives. Yes. 3 points. Oh, just kidding. It was 4 points. One for the setup of the integral, one for choosing u and dv, and like getting the correct du and the v. Uh-huh. I'll put it right here so everybody here can see. It was one for the integral, one for this part, one for the structure of integration by parts, and the last one for the answer. Okay. And then the last one, part C. Find the volume of the solid generated when the unbounded region of W, unbounded, eh? That means we go from 3 to infinity. When it's revolved with respect to the x-axis. Okay. I'll do my drawing again. But basically W looks like this. And when you revolve it with respect to the x-axis, it creates cross sections that are circles. We talked about that in the previous question. If you want to find the volume, you have to integrate the area of the cross section. What's the area of a circle? The volume is going to be the integral from 3 to infinity of pi r squared dx. You just have to find the radius. It's always going to be the distance from the function to the line of revolution. And you can do that by doing top minus bottom. The radius is top minus bottom. The radius is, what's the function? 1 over x squared. The bottom is 0 because it's the x-axis. So the radius is just 1 over x squared. So the volume, it's going to be pi 1 over x squared squared and yeah, integrate it. Let me square 1 over x to the 4th and rewrite it with a negative exponent. X to the power of negative 4. You add 1 to the exponent. You divide by the new exponent. Plug in your stuff. So here we have, you know what? Let me factor out that negative 1/3. Oh, my battery, I think it's gonna die. So I'm gonna factor out the negative 1/3 and just go ahead and plug in the infinity here. Minus 1 over 3 cubed. And if I lose, you let me know. Well, what does the first fraction become? 0. 0. And the other one is negative 1 over 27. So the answer is pi over 81. This one is 3 points. 1 for the integral, 1 for the antiderivative, and then the answer. Let me bring a charge real quick. Plug it in, por favor. All right, let's go on to number 6. Oh man, the series question. Just so you guys know, like I'm doing these questions with you guys like later, but like I'm doing them, and this is my arch nemesis. I'm always looking forward to it because I think I always get like 8 or 7 points. Like I always miss something. So I'm still looking for that perfect 9 on this one. Okay, so here we have a function. Okay. Okay, part A, use the ratio test to find the interval of convergence. That one is basically straightforward if you know what the ratio test is. And I'll tell you what we missed points on. No, it's 4 points for A. So we're gonna do the ratio test. One, the first point was for the setup, just the setup. People missed the limit notation. People missed the absolute value notation. And maybe that one you can get away with if you take off any alternating, any negatives. But I'm not gonna do it, so I'm just gonna set it up. -1 to the power of n plus 1 times x to the power of 2 n plus 1 plus 1 divided by 2 n plus 1 plus 1, and then times the reciprocal of the original. That's your first point. But again, we didn't write the limit. We didn't write absolute value. So we missed the first full point. Okay. I'm going to ignore the negatives now because that's what the absolute value is for, right? The limit as n approaches infinity is x to the power of 2n plus 3, right? I'm going to skip a step and I'm going to split them already. 2n plus 3. The denominator should be 2n plus 3. The denominator of the last fraction, I'm also going to just split it. X to the 2n times x to the 1. Okay, let's cancel out whatever we can. So we can cancel out the x to the power of 2n's. We can cancel out one of the x's with the denominator. And, well, let me just write. That way I don't do too many steps at the same time. X squared times 2n plus 1, 2n plus 3. Okay. Now we can actually take the limit to infinity. The groups in parentheses, they cancel. The plus 1 and the plus 3 doesn't make a difference, right? Okay, so now that just leaves us with the absolute value of x squared. And now we can say that it's less than 1. You could have been saying that from the beginning. Okay. Because here's another mistake what people made. Normally we take off the absolute value and we say that it's going to be -1 to 1. But then if you take a square root, you can't have an imaginary number. So in that case, take the square root now and just say plus or minus the square root of 1. And then, well, now you can be like, oh, square root of 1, square root of 1, which is -1 to 1. So use the ratio test, find the interval of convergence, justify your answer. Because they want me to find the interval, I have to test if the endpoints are going to be included, because they could be included. But even if you miss all that, you already got 3 points already. All right? This is just the cherry on top. So let's plug them back into the series and check if they converge. Okay. Test. Oh, not an x. Test x equals -1. If you look at the beginning of the problem, they give you the general term of the series. The general term is -1 to the power of n, and then it's x. So that's where I'm going to put the -1. 2n plus 1, 2n plus 1. And the series, sometimes you have to decide, you have to figure out if it starts at n equals 0 or 1, and in this case it's 0. Okay. All right, then let's see. Yeah, it's just gonna converge diverge. -1 to the n, -1 to the 2n. If you combine those, that's gonna be -1. You add the exponents, 3n plus 1. I mean, sometimes your terms are gonna be negative, and sometimes they're gonna be positive, right? Because of the power. But because they're switching, it's an alternating series. So we're gonna apply the alternating series test. In the numerator, we essentially just have a 1, but the denominator keeps growing. So because it keeps growing, it's gonna converge. Converges by the alternating series test. So I'm gonna go ahead and put a or equal on my inequality. Now we got to test 1. Again, all this work is just for 1 additional point, which is good, but don't be stressing out about this part. At this point, we already have most of the points. N is equal to 0. Plug in 1 into x, which is going to be 1. So 2n plus 1. So, do you know if it converges or diverges? By which test? Same test. Converges. Alternating series test. So then that's our interval. -1 is less than or equal to x, which is less than or equal to 1. So that's the full 4 points. That was a lot. No. Yeah. Yeah, we weren't doing the comparison test. It was a lot, but it was already like 4 points. So that's already a lot of stuff. Okay, B. Dice, show that f of 1/2 minus 1/2 is less than 1/10. This setup already should scream alternating series error test. And I already tell you, like, I always just write the original formula. Whether or not the same notation applies, but that's the original formula. The sum of the series minus the partial sum has an error, right? Because the sum of the series is like the exact answer. The partial sum is just an approximation. It could be really close, but it's not going to be exact. So when you subtract them, there should always be an error. And the error is going to be, at most, the absolute value of the next term. So we kind of have to figure out what term we should be using. And because it says that we have f of 1/2, they're telling me what x is. X is 1/2. So if I go back to my series, then it's going to be 1/2 minus 1/2 cubed, which is 1/8, right? 1/8 times 1/3. I'm only going to do one more because we don't really have to go that far. 1/2 to the power of 5. What is that? 132 times 1/5. Okay. All those were unnecessary. I was just showing you. But they want us to show that f of 1/2 minus 1/2. We got the 1/2 in the first term, right? So all you got to be doing is comparing it to the next term. So I'll go back to this. So basically, the sum of the series, we're basically using the partial sum using the first term only, which means this should be less than or equal to the absolute value of a of 1 plus 1. Basically, a of 2. You should just be looking at a of 2, the second term in the sequence. I'm going to pause right here, though, and make sure you understand why I'm looking at a of 2. I was able to figure out that this guy was s of 1 because they gave me f of 1/2 minus 1/2. And where did 1/2 come up in the sequence? It's the first term. So now I should just be looking at the second term. And we already said the second term was, we said it was 1/8, right? Times 1/3, which is 1/24, which is less than 1/10. There it is. We showed that it was less than 1/10. It was worth 2 points, this question. C. Okay, I don't need a lot of space for these. Some other questions? You could ask questions, yeah. Okay. Write the first 4 non-zero terms of the derivative and the general term. Okay, this one is easy because all you got to do is take a derivative. You can't see the, I'll just write it. That way you can see it. F of x equals x minus x to the power of 3/3 plus x to the power of 5/5 minus x to the 7/7. So again, just take a derivative. 1 minus, when I bring the 3 down, it's going to cancel with the 3 in the denominator. Minus x squared plus x to the 4th minus x to the 6th. The first 4 non-zero terms. Now we also got to get the general term. The general term was negative 1 to the n, x to the 2n plus 1 over 2n plus 1. Everything with an n is a constant. Bring down the 2n plus 1. And it should cancel out with the denominator again, because that's what the pattern has been. So the general term is going to be negative 1 to the n, x to the power of what? 2n. 2 points. 1 point for this, 1 point for this. Last one. Use the result from part C to find the value of f prime of 1/6. Okay. I see questions like this all the time in question number 6, and they basically want you to make an equation. They don't really want you to find the value. Sometimes. But first, we kind of have to figure out if we have a common ratio. Okay, plug in the 1/6 into your equation. 1 minus 1/6 squared plus 1/6 to the power of 4, 1/6 to the power of 6. Okay. That would mean that we have, well, maybe I don't have to simplify it all the way. I'll leave it like this. We have a common ratio. We're multiplying by a constant to get the next term every time. What are we multiplying by? Negative 1 over, it has to be a number because we are getting numbers out of this. Negative 1/6 squared. Because if you multiply by negative 1/6 squared every time, it does give you the next number in the sequence. That's our common ratio. So R equals negative 1/6 squared. And if you have a common ratio, you have a geometric series. So now we have to just kind of figure out what it converges to. So we have A of 1 divided by 1 minus the common ratio. Ace of 1 is the first term, which is 1. It's up here. The common ratio is negative 1 over 6 squared. To simplify it, 1 over 1 plus 1 over 36 equals 1 over 37 over 36, which equals 36 over 37. This one was worth just 1 point. You either got it or you didn't.
What's the value of prime?
When x equals 1/6. Because if you switch up the value of x, it's going to be something else. And depending on when you select, it might even diverge.
So you wouldn't like combine all four of these together?
To
get f prime.
we're not only combining the first four, we're combining infinitely many terms
Oh, to get an exact
to get 36 over 37. We just use the first four to figure out the common ratio. And again, if the common ratio was greater than 1, then it wouldn't be conversion. You would be getting infinity. I think even if the common ratio is 1, I forget the rule. Let's see. Yeah, even if the ratio is 1, it should still diverge. But in this case, it was 1 over 6 squared. I don't know how much time we have left, but you want to go over number 2? Number 2, and I'm talking about that one because that one's the BC question. I'll do the AB questions later, like clustered together. Yes? No? All right, number 2. A particle moves along the curve. Okay, we got a parametric. We got your x component, you got your y component. And they give us an initial condition. At t is equal to 4, x is at 1, and y is at 5. A, find the slope of the line tangent to the particle. Okay. Do you remember how to find dy dx with parametrics? What's dy? It's dy dt. And they do give us those derivatives already, right? Honestly, you just plug it in the calculator. I'm going to set it up by doing this. Dy dx at t is equal to 4. But again, in the calculator, basically you're plugging in ln of 2 plus 4 squared. You don't have to show this on paper. I'm just showing you. Divided by the square root of 1 plus 4 squared. The answer should be 0.701. And maybe throw a little sentence just to be safe. But that is the slope of the curve at t is equal to 4. I'll leave it like that. You can check out the rubric to see more. It was worth 1 point. It's not much, but it's something it's on its work. Find the speed of the particle. Do you remember your formula for speed? Yes, for like regular functions, but there is a specific formula for parametrics. So know your formulas. That way, you write it down and it gives you like something to do after that. And again, this is all calculator work. Find the speed at t is equal to 4. So same thing, right? You're gonna take your calculator, carefully plug in the parentheses, and you're gonna do the square root of 1 plus 4 squared, ln of 2 plus 4 squared, and you get the speed. It's gonna give you 5.035. We don't have any units, I just leave it at that. But then there's another part. It says find the acceleration vector. Find the acceleration vector at t is equal to 4. So if the velocity vector is just the regular equations, all you got to do is take the derivative individually. So the acceleration vector is 1/2 to the power of what? Negative 1/2. Apply the chain rule. Times 2x. Okay. Now the second derivative, 1 over u. Wait, it was 1 over x or 1 over t? 1 over t. 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 Okay, 1 over u, which is 2 plus t squared times 2t. You don't even have to clean it up because we just want to know that we did the derivative correctly, and then you have to evaluate it. But you know what? I'll clean it up a little bit. Look, this one and this one cancel. This t is a part of your numerator, so I'm going to go ahead and put 4 already. Then this guy is going to be a part of your denominator. So we have the square root of 1 plus 4 squared, comma, 2 times 4, because of this guy, divided by 2 plus 4 squared. And just simplify it. Square root of 17, 8 over 18. Technically, you could leave it like that. Don't worry too much about rationalizing it, and I'm pretty sure the rubric had it like this. There's 3 points in this question. 1 for this component, 1 for the y component, or technically y double prime, and 1 for the speed. Okay. C. Find the y-coordinate of the particle's position at 6. If you want to find the y-coordinate at 6, you got to get the antiderivative of y prime. Where does 6 go?
No.
Plus 6 over here? No. No.
Isn't it
The integral from a to b. I'll write that so far. A of b. Okay. So the question is, where does 6 go? Technically, yes. I took a of b, but yeah, a to x, and that's my x, my t. So now we just have to figure out a and f of a.
Is it 4? Can you start at 4?
When t is equal to 4, the y component is located at 5, because it was up here in green. When t is equal to 4, the y component is 5. And again, it's just all calculator work. Plug it into your calculator and you get 11.571 is the y coordinate when t is equal to 6. 3 points. 1 for including the plus 5, the initial condition, 1 for setting up the integral, and then the other point for the answer. Okay, last one. Find the total distance the particle travels from 4 to 6. Do you know your formula for total distance when dealing with parametrics? That's without parametrics. This one is without parametric functions,
That's like
which is total distance traveled. Basically, you're just integrating speed, dt. The integral from 4 to 6, you can even relieve it like that, but I'll write it better. X prime of t plus y prime of t. Type it up in your calculator. You get 1.2, no, not 1.2. You get 12.136. 2 points. The setup, the answer. Yeah, those were the BC questions. I'll stop it right here. Plus, time's kind of running out. And we'll do the AB ones maybe on Friday. Yeah.